How many hours of sleep that college students really get? Which pizza topping is most popular? Can your Spotify playlist predict your mood? So this can help you to answer these questions and more. That's what course is about. Turning everyday curiosities into real data-driven answers. Welcome to Introductory Statistics. I am Dr. Thiên Lý. I have been teaching and researching statistics for about 15 years. My research focuses on network science, where I study how the connection between different components of complex system shape the outcomes. For example, how the connection between people, how people interact, shape the epidemic outcome like COVID-19. My goal here is trying to help you to learn statistics in a very practical and engaging way. So from that, you can use statistics, apply it in your daily life and in your career. In this course, we will explore how to collect, analyze, and interpret data to better understand the world around us. Statistics is more than just numbers. It helps us to think critically, finding patterns, and from that making the best decision based on evidence. So before we start crunching the numbers, let us just look at some real-world applications of statistics. So here in this slide, you see that we have a different application of statistics in industry, in vaccine production, in weather forecasting. I think one of the most cutting-edge thing right now is self-driving car. So in industry, you can see that, for example, in car industry, right? A car company, they have they will produce 1,000 of components each day, and for sure we won't have time to check all of them to make sure. So basically, like in order to make sure the batch produced by the machine is safe, right? Now, for example, you need some quality control procedure. So here, like instead of we check all the parts produced by the machine, now you just take a sample, maybe 200 parts or something like that, and you start to check each element in sample. And if the sample it passes a certain kind of a standard test, and then from that you can assume that the whole batch of 1,000 of the components produced by machine that day is good, and at the time you can use them to assemble the machine like the car. For example, here in vaccine trial, for COVID-19 vaccine trials here, so you can see that before we can make a mass production to make it available for all people, we have it has to go through a very scrutiny process, including a multiple phase of study. So after the scientists they work in their lab and they find out the vaccine is effective to stop the spreading of the virus, right? And then they start to do some trials on animals, like mouse and rabbit, and eventually monkey. And so after all of them show effective of the vaccine, and then we start to do different phase on human. So in the first phase, often we have a small group of 10 to 100 people, and typical procedure is that we will divide by two group. One group just receive a sugar pill, and another one will receive maybe just some sugars kind of injection in the body, which it has nothing to do with the virus. And another group which with real vaccine they just invented, and from that they will observe this group in terms of when they contract the virus and how their immune system behave. And say if in this phase we show like people who get the vaccine is do much better than the group not get a vaccine by some statistical procedure, they will start to go to phase two, where the participants increase to hundreds of people, say maybe 500 people. And again, you also break them into groups, placebo and the treatment, which is the vaccine with the vaccine. So in this figure, you can see like people with dark yellow and bright yellow. Right? So you can see there are two different groups. One is receiving the vaccine and one receiving placebo. And then like after that, they also let them just, do their own thing. And some of them may, in each group, will contract with the COVID, right, eventually. And then we also observe how the body responds to the virus, right? And so if it shows that the vaccine effective, right? And then you go to the last phase, which in this phase you have thousands of people, and you recruit say maybe 40,000 people in your trial, and then from that 20,000 will receive the placebo and 20,000 will receive the vaccine. And again, you test again. There's some statistical procedure there, and then if you see the vaccine is really effective compared to a non-vaccine group uh, in terms of, say, death or hospitalized. Another time, we can uh, start to, apply for some FDA procedure to start for the mass production of the vaccine and make it available to all people. So this not only work for the vaccine COVID-19, but all kind of vaccine are new kind of drug. It has to be a very careful procedure, different phase, and sometimes it takes years to get approved a new drug, a vaccine. And here, like you can see in weather forecasting, right? I believe most of us use the weather forecast to plan our event, like barbecue or outside, birthday party, something like that. And then you can see that you see, like for example, in this page, we have like 94 degree, 2% of rain, and 2% rain, which means like if you see such thing like 100 times, you should be back about 2 times it's going to rain. So which means like it's unlikely to be rain, right? So if you are going to make a barbecue party and just no hand do that. But say if you see 99% of rain and you still want to do that, I I I think you should rethink about your plan, right? Maybe try another time of day, or maybe with no rain, or maybe just try another day. So where the number come from? If you ask yourself, are they only, some people make up that number and put on the app? Uh, no, actually, basically, it's just there's some underlying model, dynamical model here, and from that they can, collect a sample from different station, and from that they run the model, and they give you this kind of input output. And the latest one is self-driving technology, which is also the cutting-edge technique right now, which we say about AI, artificial intelligence. So basically, what happening is that like order for the car can drive itself, it has to be able to recognize object like a human being, right? It should be recognized. It stay in the lane. It should be able to recognize. Okay, can it make the switch to another lane? Is there any car aside? Uh, them itself to make sure the switch lane is safe. Maybe it should be able to recognize the red light, so it has to stop or bring a green light. It can still just um, keep going, right? Where it should make a turn, something like that. So in order to make it happen in a car with this technology, they will have multiple camera from different direction. And if we just keep recording the signal different angle from a different angle, and it's go to some kind of deep neural network tool, which is the cutting edge technique in statistics nowadays. So basically, from that, it will be able to recognize the subject and we will make a decision. Okay, here it come very complicated procedure, but more or less the building block initialized and still just statistics and mathematics. It has a foundation of that. So now your turn. Let's look at this, okay, noodle legend. So here is the legend. Maybe some of you already heard about that. Maybe for some of you, maybe the first time. But here, legend, people often say most college students are broke and survive on instant noodles. So my question for you is that true or false? You just spend maybe time to think about that. It's true or false? What do you think? So the answer here is that it may be true for some people, but in general, it's not true. So in order to answer the question, we need to do some survey to get some kind of data collection. And from that, we can see whether this legend is true or false. So here, like the source data from the U.S. Government Accountability Office, GAO, in 2024, about a study about college students' federal data helped to better understand food insecurity. So food insecurity here means just sometimes not have enough food to eat, have to eat less. And here, like the figure they find out in the survey, they did survey about 10,000 students from different colleges. So in average, like you see that about only 23% of the first column, the first chart here, just 23% of them say that they have issue with food security, insecurity. So sometimes they don't have enough food. And the high estimate happened with some community college, which is second column about 42%. So if you just look at some community college, and you get high estimate. And we do have a low estimate, about 12%, but we don't have in this figure, which is only about 12% in some certain university, say a private sector, they face food insecurity. So you can see that for sure from this number, the first two charts, you should be able to recognize that the claim here, not true, right? Not true. It may happen for a certain group of students, but most students don't have this kind of status, right? And in fact, uh, about 62% of students get a part-time job when they are in college, and about 70% of them get some kind of financial aid, like scholarship, or get a support from a family. So this is tell us, right? Actually, like how we can verify a claim using a data-driven way. And this one basically is just what the statistics about. There are certain curiosity, a certain claim, a certain thing which is we're not sure it's correct or not, right? And then in order to answer this kind of question, you need the data to support your conclusion. And you go ahead and collect the data, and from that you can draw conclusion. So in this chapter, you learn the key terms and definitions which form the foundation of statistics. We will learn about the terminology, basic terminologies. We will learn about how people classify the data. We will learn about how different sampling procedure is performed, and which kind of procedure give you reliable answer for the question you interested in. And we also learn about how different what are different way people use to collect data. So first thing first, let's look at some key terms. Okay, so here you can have the term statistics first. So in short, we can think like it's just a science where you make sense of data by collecting, analyzing, and from that you draw a conclusion. So it kind of data telling story, right? But evidence based. And you have another term called probability. So here, like It's just a math behind, right? Statistics rules. So in order for statistics to function and make it reliable, you need some math, right, behind that. And we just say it is probability. And in the probability, we deal with likelihood event occur. So this picture in this slide, it also tell you, how typically a statistical procedure is conducted. So in the left figure, like you have the whole population, the big, you have more people here. So say, you care about maybe the annual income of U.S. People, right? A U.S. household, and you have so many household, and for sure, if you want to collect all of them, it will be very time consuming, and it's costly, time, money, and for sure, often the case you won't get the data from all of them, because what if some of them don't want to tell you about their income, right? So in order to make it work, right? So this we just take a sample of that. So you don't survey all people, but maybe you should survey 1,000 people. This is doable, right? Maybe in 1 or 2 days you can get that much information, and from that, you just use as a sample the data from the sample you collected, which is household income of each family in your sample, and you can make an inference for the whole population. And so this provide you the tool to do such a thing. Another terminology is population. So here, like it's just basically the complete collection of all data interested. So population here is has a more general meaning. It's not just the people, right, in the demographic. It can be, it's just the thing you're interested in. So for example, you're interested in uh, say the um, the plant on the earth, right? And say you want to see what the average age of say maybe we just narrow it a little bit, average age of some kind of plant, right? In the earth, how long they live, right? And other time the population will be all the plant you're interested in, right? I say you're interested in the uh, yield of green bean, right? Another time, like your population at that time, just all the green bean plant, right? Uh, you're interested in the say the number of ants in colonies, right? So basically, if you're interested in such a thing, and at other time, your population will be all colonies of ants, right? Sample, which is a sub-collection of population, and again, because the nature of uh, thing is that you cannot get the whole population, right? You cannot get access to. A lot of time, it's just very time consuming, costly, and sometimes it's just not doable, not doable. So in the example I told you before, right? If you talk about annual income, household income, what if some people don't tell you the income? They have a right to do that, right? To not answer your question. So because that, you need to take a sub collection of population, which is sample, and from that you study that sample instead. And now you use the study you find on a sample to make a conclusion for population. So here's sample, and variables here is represent the interested measure from each subject in the population. So it depends on what you care about, right? So if you care about, say, the blood pressure of U.S. people, right? And other time your variable will be blood pressure. But if you care about their height, weight, and other time your variable will height, weight. And data here just the collection of observation interest. So then height, salary, and population index. So data basically is just the value you collect from each individual. So if we think about the height of U.S. adult, right? So say if you care about that, your population will be all US adult. And from that, you take a sample, right? Maybe 1,000 people, and you measure their height. And so each person will give you a data point, which is the height. And then parameter. So parameter is a numerical value, a measurement describe the characteristic of population. And this is the ultimate thing we want to find. We want to know. And no one know, right? No one know. So for example, like you care about the annual income, household income of US people, right? So it must be the average annual income. So it must be a number. So say, for example, I have the power where, I know all the income people in the US, I have a family in the US. And from that, I just add up all number and divide by the total, right? And I will get my parameter, which is underlying truth. But the problem is that you don't know that because you don't get all the data, right? So this is why you need to work with a sample. And from a sample, you produce some analog, right? Something similar, but with a sub collection. And that measurement we call statistic. So statistic is just a numerical measurement describing some characteristic of a sample. So say if you have a sample of 1,000 household, then you can calculate the average income of that sample, right? Eventually, you learn how to calculate median. You learn how to calculate variance, right? You see how they vary between different family, right, compared to the average. So more or less, you can see that you learn this statistic. Pay attention. Okay, we don't have S here to um, give a educated guess for the parameter, which is under truth you care about. So let us look at an example to formally formulate these terms. So here, like this example is 111, which is the first example in section 1.1, right? About U.S. mean average height. So here you randomly choose 1,000 American men to conduct survey and find out the average height of the group E58. So in this case, the population interest is all American men. And parameter here is the average height, right? And often in a Latin notation system, we denote mu. We call mu, okay? You see this term again in this class, in this course. The sample here will be 1,000 chosen men. And the value we obtain from the sample, which is the average height per sample phase. So this is a statistic. And the variable we care about is the mean height, right? And we can say a little bit further, like the data here, which is the height of each man in the sample. So let's look at the first quiz here. Randomly choose 1,000 family to survey the average income household in America, right? So again, the target here, the average household income of household in America, right? Annual income. And the average income of this selected group is 69,000. What best describes the amount of 69,000? As shown below. So we have like 4 options. And specify what population, sample, parameter, statistic. So let's think about it a little bit. So in this case, the thing you care about is the population you care about is all American households, right? So your population will be all American households. And the sample you can assess is 1,000 chosen household, right? And the parameter you care about, which is the ultimate thing you want to know, is the average, right? Average household income in the US, right? But because you cannot get all data, right? You need to do sample, and which is will produce you the statistic. So the statistic here is just the average of the annual income of the family in a sample, right? So in this case, yeah, statistic here, which is the average. So maybe we just write it here, make it clear. Household income in the sample. And this is actually just the $69,000, right? We have here. The average income, this selected curve is 69,000. So again, so from that, you can see that the basic right of the amount 69,000 here is statistic, right? Because it's obtained from the sample.